light. Light is a form of energy. It enables us to see the world around us. In the absence of light, we are unable to see anything. Let us understand how light enables us to see things around us. When light, say sunlight, falls on any object, say a flower, the object, here flower, reflects the sunlight falling on it in all the directions. When the sunlight reflected by the object enters our eyes, we are able to see the object. Thus, light enables us to see the objects from which it reflects. When light traveling in a medium falls on a surface, then it returns back in the same medium. This process of sending the light rays back is known as reflection of light. Reflection is the phenomenon of bouncing back of light in the same medium in which it was traveling when it falls on a surface. Characteristics of the image formed by a plane mirror. In class 7, you have learnt the characteristics of the image formed by the plane mirror. Let us recall the same. The image on a plane mirror is of the same size and shape as the object. The image on a plane mirror is erect. The image formed on a plane mirror is at the same distance between the mirror as the object is in front of it. The image on a plane mirror is laterally inverted with respect to the object. You know that in an image formed by a mirror, the left of the object appears on the right and the right of the object appears on the left. The left-right reversal of an object and its mirror image is called lateral inversion.
Formation of images by a plane mirror. When we look into a plane mirror, we see our image situated behind the mirror. When we move towards the mirror, our image also moves towards the mirror. And when we move further away from the mirror, our image also moves away from the mirror. In every case, the distance of our image from the mirror is equal to our distance from the mirror. Let's prove this fact geometrically by drawing ray diagrams and using the laws of reflection of light. When object is a point source of light, a point source of light O is placed in front of a plane mirror PQ. The rays of light starting from point O travel in all directions. Consider two directions, OA and OC, starting from point source O, which obey the laws of reflection and get reflected along AB and CD. Draw normal to the surface of mirror PQ at the point A and C. Then draw the reflected rays at the point A and C. AB and CD are reflected rays. Extend them backwards. They meet at the point I. For a viewer's eye, at E, the reflected rays AB and CD appear to come from the point I. Figure 6.7. Since the reflected rays do not actually meet at I, but only appear to do so, we say that a virtual image of the point O is formed at I. If we join OI and measure OL and LI, it is found that they are equal. This proves that image is formed as far behind the mirror as the object is in front of it.
When the object is an extended source of light, an extended object or bigger object like a pen or a pencil can be considered a collection of a large number of point objects. An extended object, say a pencil, is placed in front of a plane mirror, MM'. We take two extreme points, A and B, of the extended object into consideration. A beam starting from point A after reflection from a plane mirror appears to come from point A. So, for point A, we get A' as its virtual image. Similarly, from point B, we get B' as its virtual image. Thus, A', B' is the virtual image of an extended object AB which is laterally inverted. The image is at the same distance between the plane mirror as the object is in front of the mirror. The image is virtual, erect, and of the same size as the object. Regular and irregular reflection.
When we hold a plane mirror in front of us, we see our face in it. This is because the entire light that falls on the surface is reflected in a definite direction. Such a reflection is called regular reflection.
The phenomena due to which a parallel beam of light on striking a smooth, highly polished surface, like a plane mirror, is reflected back as a parallel beam of light is called regular reflection of light.
When we hold a cardboard in front of us, we are not able to see our faces in it. This is because the entire light that falls on the surface is reflected in all directions, irregularly, in a scattered manner. Such a reflection is called diffused reflection.
The phenomena due to which a parallel beam of light on striking a rough surface, such as cardboard, gets reflected in various directions is called irregular or diffused reflection. Differences between regular reflection and irregular reflection. Parameters, points of difference, nature of reflecting surface, reflected rays, image formation. Regular reflection. The reflected surface is smooth and highly polished, like a mirror. All the parallel rays reflected from a smooth surface are parallel. Images, like seeing our face, are formed. Irregular reflection. The reflected surface is not smooth but irregular, like a cardboard. All the parallel rays reflected from a rough or irregular surface are not parallel. Images are not formed. We cannot see our face on a rough or irregular surface. Multiple images. When two mirrors are inclined to each other at an angle, many images of the object placed before them are seen. This is because the image formed in one mirror acts as the object for the other. Many images formed in this manner are called multiple images. Kaleidoscope. The kaleidoscope is a device that uses reflections to produce patterns. It consists of mirrors inclined to each other. The mirrors form multiple images of objects in front of them. This creates beautiful patterns, which changes when the kaleidoscope is rotated or shaken. Uses of plane mirrors. Plane mirrors are often used as looking glass, as reflectors in solar cookers, to provide a false dimension, a sense of greater space, when the workplace is very small. The effective length of the room appears to be increased by keeping the two mirrors facing each other when fixed on the opposite walls of the room. To provide a false dimension in showcases displaying jewelry, wristwatches, spectacles, etc. Light reflection causes brightness and sparkle by keeping the two mirrors facing each other when fixed on the opposite walls of the showcase. Figure 16.15c. In a barber's shop, to show the customer the back of his head, for seeing his haircut, or the construction of periscope, kaleidoscope, etc. Dispersion of light. The phenomenon of splitting of white light into its component colors on passing through a transparent medium like a glass prism is called dispersion of light. The band of 7 colors formed on a white screen when white light passes through a prism or any transparent medium is called spectrum of white light.
Human eye. The human eye is a light-sensitive organ which enables us to see the beautiful world around us. The eyelids act as the shutter of the eye and protect them from injury or prevent any object from entering the eye. It also shuts out light when not required. The eyeball is almost like a spherical ball. It has a diameter of about 2.3 centimeters. The outer part of the eye is composed of 3 layers of tissues, namely sclera, choroid, and retina. Sclera. It is the outermost covering of the eye. It is made of white, tough, fibrous tissues. It protects the vital internal parts of the eye. Cornea. The sclera layer continues in the front of the eye as the cornea. This is a transparent white portion of the eye, which covers the transparent bulge on the surface of the eyeball. It allows the light to enter in the eyeball, iris and pupil. Behind the cornea is the iris. It lends color to the eye. The iris has a central circular aperture called the pupil. The iris regulates the amount of light entering the eye by adjusting the size of the pupil in the following ways. A. If the light is dim, the iris makes the pupil expand in order to allow more light to enter the eye. B. If the light is bright, the iris makes the pupil contract in order to decrease the amount of light entering the eye. The iris consists of muscles that expand and contract the pupil. Choroid. The dark gray layer attached to the sclera on its inner side is called the choroid. It is richly supplied with blood vessels. It darkens the eye from inside and hence prevents any internal reflection. Crystalline lens. It is a transparent crystalline biconvex lens situated just behind the iris. It is held in its position with the help of ciliary muscles. Retina. It is the innermost delicate membrane having a large number of nerve cells called rods and cones. The cones are sensitive to color, while the rods are sensitive to the intensity of light. Optic nerve. Optic nerves are about 1 million separate nerve fibers that connect the rods and cones of the retina to the brain. Its function is to carry optical messages in the form of electric signals to the brain.
Working of the human eye. The light coming from an object enters the eye through the cornea and the pupil. Light coming from an object enters the eye. The lens focuses the light rays to form an inverted image on the retina. Rods and cones of the retina get activated and generate electric signals. Optic nerves send electric signals to the brain. The brain interprets these signals and renders the erect image of the object. Blind spot. At the junction of the optic nerve and the retina, there are no sensory cells, rods or cones, so no vision is possible at that spot. This is called the blind spot of the eye. Persistence of vision. When the light coming from an object falls on the retina of the eye, the impression of an image does not vanish immediately from the retina. The impression of the image lasts for 1/16th of a second. So, if still stationary images of a moving object are flashed on the eye at the rate faster than 16 per second, then the eye perceives this object as moving. This is called persistence of vision. Power of accommodation. Power of accommodation. The ability of the eye lens to adjust its focal length so as to see the objects located anywhere is called the power of accommodation. The minimum distance at which the eye can see objects very clearly without strain is called the near point of the eye. The farthest point up to which the eye can see objects clearly without strain is called the far point of the eye. Defects of vision and their correction. Sometimes the eye may gradually lose its power of accommodation. In such conditions, the person cannot see the objects clearly and comfortably. The common defects of the eye are the following: nearsightedness or myopia. A person with myopia or nearsightedness can see nearby objects but cannot see distant, far-off objects.